When we play around with these normal distributions now, we have a couple of different ways to get things like p-values or to get endpoints for a confidence interval. One is the simulated sampling distribution here, and two is going to be this theoretical normal, provided we know the middle and the spread. So I'm going to double check this calculation right here by just reviewing that idea of the z-score. So for this number right here, it's z-score. And remember, what does z mean? Z is how many standard deviations away from the mean is this? How many STDs from the mean? So we first find out how far is it from the mean. So that would be 0.72 minus 0.673. And then we figure out that distance is how many of those, how many times does this go into that spread? So then we do division. And when I did that earlier on the calculator, I got 1.88 about. So that would be the z-score for this number. It's 1.88 standard deviations from the middle. So 0.72 is about 1.88 STDs from 0.673. And when I look at, instead of the actual data values, instead I put z equals 0 in the middle. This over here would be z equals 1.88. I'm going to get the same kind of tail probabilities. So Stacky earlier was saying that was about 3%. When we just work with z-scores, that's called a standard normal distribution. So using z-scores is what's called a standard normal distribution. There we go. I'll do this calculation one more time. So first I had the bootstrap version, and 0.72 was about 3% or 2.5% away, or in the upper tail. And when I use the normal using the mean from my data and the standard error for my sampling distribution, I get about 3%. This time I'm going to go back to stat key. And for the normal, I'm just going to leave the 0 and the 1 there. So if you put 0 in the middle and say the standard deviation is 1, that just counts standard deviations, which is a z-score. So I'm not going to edit the parameters. I'm just going to enter my z-score. So that would be a right tail. The z-score for my data was 1.88. Is that true? Put back on my calculator. Yep. Okay. And what I should find is I get the same probability in the tail. So we have 3 ways to look at these things. And this is just going to give us more freedom in trying to make calculations about a p-value for a situation, confidence interval for a situation. So we have the simulated version. We have the normal based on the sample data. And then we have the idea of a z-score. And the question is, well, why would we bother with z-scores when we already have the sample data? So that's the last point I want to make here, and we're out of time. The idea of a standardized test statistic. The standardized test statistic is the z-score that I'm talking about here. So an example, like for a proportion, would be something like p hat minus p over the standard error. For a mean, it would be x bar minus mu over the standard error. So it's always some value of interest minus the center of the distribution divided by the standard error or standard deviation. So this would be for a mean. And one reason we look at this standardized version instead of the actual mean, the actual sample mean or the actual sample proportion is based on other work we've done. And that 95% rule, this would be plus 2 standard deviations to the right, minus 2 standard deviations to the left. We get the usual 95% in the middle. If we calculate a z-score and we see the z-score is bigger than 2, then we say, oh, that's a high z-score. So we have this cutoff in the sand that if a z-score is greater than 2 or less than -2, that's unusual. And then we start to wonder, what's going on here? So up here, z is greater than 2. This is unusual. So it just kind of standardizes the way we define this unusual data idea, meaning there's something weird with our assumption or there's something weird with our data. Z is less than -2. So we can, based on a sample information, sample data, we can calculate a z-score, and right away, if we see the numbers outside of this -2 to 2 thing, we go, whoa, something's going on. And if it's inside that range, you're like, ah, this is pretty typical, no big whoop. So it just gives us another way to talk about what's usual and unusual, and it's a common practice in statistics. So over the next couple of weeks, in addition to running these simulations, we're also going to look at these z-scores. And based on those z-scores, we're going to run these theoretical calculations to see how they compare with our simulated calculations. And for the most part, what we're going to find is they're pretty close to each other. They're going to be about the same. Will they be exactly the same? Answer is no. It's like flipping a coin, it's different every time. Right? There's a lot of variety in life, but they're going to be similar. So this right here is section 5.1. 5.1 mostly focuses on hypothesis tests and these z-scores and normal distribution. Section 5.2 kind of does the same thing, but talking about confidence intervals. So I'm going to talk more about confidence intervals in the next class and how z-scores are related to confidence intervals. So that's it for now. If you need any help catching up, check me out in office hour or schedule an appointment soon.